Redis native data structures. Welcome back in this 5 minutes to learn Redis series. I cannot tell you everything in 5 minutes, there might be shortcuts. This content is available both as a video on my YouTube channel and as a post on my blog in French and in English. In this first part, I give a short overview of the most commonly used Redis native data structures. What can they be used for, what can be stored inside, how to use it. In the next part, I will describe the remaining native data structures. But first, a short reminder about Redis. Redis is an in-memory key structure database. It can store up to 2^32 keys. Each key can be 500 megabytes long and contains a value. The value is a data structure. Redis has 10 native data structures and can be extended to support any kind of data structure from JSON to graph database or full text search engine. Each key can also have a TTL, time to live or expiration, to delete it automatically. For each of the supported data structures, Redis enables you to manipulate the structured data directly in place with atomic command without worrying about concurrency or network traffic and bandwidth. The first one is a string. A string can store a series of bytes up to 500 megabytes. Eventually non-printable, it is binary safe. You can store HTML generated snippets, serialized JSON objects, images or PDF files and so on. Redis has a basic understanding of a string and some manipulation commands. It can store arbitrary bytes or numeric values. Redis can atomically increment or decrement numeric values in place. Regarding text values, Redis can append a string at the end or return a specific number of bytes from a specified position. Strings can be used to distribute content, to implement atomic counter or logs, to store positional records. Strings combined with TTL and eviction policy are the preferred structure when implementing a cache. Then the next one is a set. A set stores an unsorted set of unique items. It can store up to 2^32 different items. Each of them is a Redis string and can store up to 500 megabytes binary safe. I never tested these limits, but if you give me a machine, I want to try. Redis can manipulate a set in place to check the existence of an item in the set, to add an item, to remove an item from the set. Furthermore, Redis can also execute cross-set commands such as union or intersections. Sets can be used to implement indexes. A set can contain the list of customer keys, then this is a primary index. But there can be also one set per possible first name with a list of customers having this first name. This is a secondary index. Redis can easily and quickly retrieve customers' identifiers by intersecting the sets. Then the sorted sets. A sorted set is a set with a numeric score attached to each item. This is sorted by score and it has more commands such as give me the top 10, last 10 within a score range. It can be used to store time series when you use a timestamp as a score, but it can also use to store leadership and leaderboard, and it is also used as indexes for range queries. So you can query to have customers with age between 30 and 50. Lists. A list can store up to 2^32 items and keep the item rank. Redis can add or remove an item at the bottom or at the top of a list. List can be used as a list, a stack or a queue. They also support some blocking commands such as get the next item if there is one, or wait until there is one. Redis can also execute cross-list commands to get and remove an item from a list and add it to another list. This can be used to implement some kind of workflows. They are very useful to implement job queues with several consumers. Hashes. A hash is a record. It can store up to 2^32 fields, each of them with a field name and a field value. And the field names and field values are Redis strings. Redis can read or write selected fields of a hash in place. This can be used to increment the field age of customer XYZ or to update any field. Hashes are used to store any record, customer, product, assets, events, operations, user sessions, and so on. Well, if you found this content useful, you can share it. Don't forget to press the like or don't like button, both are very useful for me. And if you want to learn more, you can subscribe.